We have to think of 5G not as an extension of 4G, but in the COVID era as an enabler of a whole new way of living and working. So there needs to be a change in mindset about 5G.
To another episode of Engati CX. I'm your host Soham, and today we have the pleasure of welcoming Ravi Prasad to our interview series. Let's begin with a quick intro of Engati. Engati is the world's leading multilingual full chatbot platform available across 14 channels with 30,000 bots created across 186 countries in every domain and use case. Engati has also been recognized as a top platform by Enk.com, Tech World, CIO, and many others. We run the Engati blog, video channel, and the Engati CX podcast, receiving upwards of 300,000 visitors annually. And now for our amazing guest. Ravi Prasad has 35 years of experience as an entrepreneur and consultant in high technology industries in USA and India. He has been rated by Analytica as the 19th most influential individual in telecommunications in the world and 42nd most influential IoT expert in the world. Welcome, Ravi. We are so thrilled to have you on board.
Yeah, it's a pleasure to be with you. I'm so grateful to all of you at Engati for giving me this opportunity to speak with you about artificial intelligence technologies in the telecommunications sector. And it is very kind of all of you at Engati to invite me on your program. Yes, yeah,
We are honored to have you.
yeah,
Yeah.
thank you. Yes.
So my first question to you is, what are the new technologies that the telecom sector is adopting? What changes will we get to see globally?
Well, the COVID pandemic has drastically changes the way people live and work, and the telecommunications sector has got to adapt to that. And for that, they need to introduce a lot of new technologies. There'll be a greater emphasis on smart cities, smart factories, Industry 4.0, video conferencing, M2M, machine to machine communications. And IoT, Internet of Things. A worker working from his residence in one country could well be remotely controlling a machine in a factory in another country. And also, more governmental services and civic services will be delivered remotely, especially in the smart cities. Uh, Video conferencing, tele-education, telemedicine, electronic commerce, digital payments, Netflix and Zoom, video conferencing, wearables and Fitbits in telemedicine, AR, VR, that's augmented reality and virtual reality. Now, all of these are causing increased congestions of the networks. And these types of applications of smart cities, telemedicine, uh, tele-education, video streaming, digital payments, they require reliable, always on, low latency, and high bandwidth connectivity. So telecom operators will have to optimize their networks in real time to handle the rapidly changing traffic patterns. In fact, they will need to forecast how and where there would be surges in traffic and drops in traffic. And so telcos will need to implement various technologies of 5G, the SONs, the self-optimizing networks, AI and ML. That's artificial intelligence and machine learning, deep learning, big data analytics, cloud computing, edge computing, fog computing, and mist computing, um, IoT and M2M, that's Internet of Things and machine to machine communication. Then also, this working from home will lead to new challenges in cybersecurity and in network security. Um, Ever since the pandemic started, there's been a large increase in cybercrime, cyber attacks, ransomware, social engineering, and phishing scams. So telecom operators are now facing new challenges on network optimization, network security, diagnostics, and they will require to implement innovative methods of customer interactions, such as virtual assistants, customer analytics, using big data analytics, artificial intelligence, chatbots, and so on. Now, in India, we have seen significant changes in voice and data traffic patterns and of OTT, that's over the top services and apps. Because the major business districts were closed, there was a steep fall in the data and voice traffic of the base stations in those locations. And also because traveling and commuting decreased, there were falls in mobile voice and data usage, as well as in roaming. In fact, roaming has taken a big hit. But on the other hand, because of the most white collar workers started using video conferencing, such as Zoom, then stay at home has increased the viewing of the entertainment video streaming, such as Netflix and the TikTok types of videos, the usage of the messenger services and social media such as WhatsApp, Facebook, YouTube, Instagram, their usage rose dramatically. The COAI, the Cellular Operators Association of India, it asked the video streaming services, Netflix, Amazon, Prime, Disney, to lower their video streaming quality from HD to SD, from high definition to standard definition. And also, COAI asked them to stop the advertisements and then the pop-ups, because these advertisements and pop-ups use very high bandwidth. So I also saw a report that there was a threefold increase in voice over Wi-Fi video and audio calling. And therefore, the operators were forced to compromise on the call quality, and they had to switch to lower quality speech coding codecs. So telcos, which are heavily cloud-based and who have the virtualized network functioning, they are better able to scale up and scale down if their network functions and services are automated over a containerized network applications cloud. So this COVID pandemic will require a lot of business processes and industrial processes to be totally redesigned. Digital twins will need to be adopted on a wide scale. Now, in digital twins, what you do is you use a virtual model of a physical asset to simulate how that asset will work under various conditions. So, smart factories, Industry 4.0, IoT networks and sensors, all of these will require digital twins. So, I see the use of digital twins in the industrial sector increasing greatly, and also far greater implementation of Industry 4.0, smart factories, IoT, M2M machine-to-machine communication. Now, to deal with all these changes in traffic patterns, and in fact, as I told you, the patterns have changed very greatly. New routing strategies, server balancing strategies will have to be formulated and implemented quickly by the telcos. So for this, they will require artificial intelligence, machine learning, deep learning. All these are required. And in fact, many of the solutions will come from entirely new domains of knowledge, totally outside the telecom sphere. And new types of intelligence, not just human artificial intelligence based on human intelligence, but artificial intelligence based on other species, the way other species solve problems. And the study of fungi, slime molds, amoebae, bacteria, bees and ants, insects like bees and ants, can help greatly in designing the new telecom and internet networks. So let me just go ahead with elaborate on this. There is a single cell amoeba slime mold called Physarum polycephalum. Now, we have known for some years that this amoeba, Physarum polycephalum, can be used for efficient routing and rollout of fault-tolerant networks. That is because if you put this amoeba, it's closely related to the malarial parasite. If you put this Physarum polycephalum in a drop of water and put numerous food sources around it, numerous nutrients and food sources around it in different locations, it quickly finds the most efficient route of connecting amidst these numerous nutrients at different locations. So what you can do is you can put a telecom map of your various telecom networks, the cities and the nodes and the places you want to interconnect and roll out new networks. And if you kind of put this, overlay this with a polycephal, this amoeba, then you can very quickly get a good idea of how to roll out your network. Um, and then insects like bees and ants are much better than humans in solving a lot of complex logistics and routing and traffic congestion problems, and also at site selection. If you have heard of the famous, the traveling salesman problem. Now, this traveling salesman problem cannot be solved exactly, and even supercomputers take a long time to come up with an approximate solution. But if you look at the way bees go from their hives to various flowers to collect pollen and go back to their bees, it is a highly optimized and efficient way of routing. They find the most quickest and most efficient route to go from their hives to various flowers and back. And they actually build their hives in the most optimal location. So again, if you overlay a map of your telecom network with and then also see how bees and flowers go around that, you can get some very good ideas of how you should roll out your networks, where your nodes and servers should be, where your base station should be, and your routing protocol. Look at other insects like ants. Like ants, you'll always see ants move in a single row in a very orderly way, and you never ever see any congestion. So each ant varies its speed and direction in synchronization with other ants so that there is smooth progress. And now this can provide a lot of insights for building congestion-free networks. In fact, there is a model called Anternet, which is an internet model based on how ants move around and how the ants avoid congestion. There is a FunNet, which is how the fungi, which is an internet routing model based on the fungus I told you earlier. And you have Anternet, which is the internet routing model based on how ants will move in the same typical topology. So then another thing is, also not just the new ways of doing business require new telecom technologies and new for which the telecom operators will have to implement all these new technologies. But also these new technologies can introduce new ways of doing business. For instance, in the media and newspapers, there have been a lot of layoffs and journalists have lost their job. So you can use GPT-3 to write news articles. Another point I wanted to make was about Aadhaar. Instead of contact biometrics, now people will be reluctant to place their fingerprints on the fingerprint scanner because of COVID. They don't want to touch something where somebody else has put his fingers. So India can use what are called zero knowledge protocol proofs. So you replace your biometric KYC, know your customer, with what are called zero knowledge protocol proofs. This is actually a technology, cryptographic technology, which is used in espionage, invented at MIT in the 1990s. So you can use these zero knowledge protocol proofs together with probabilistic Turing machines. So in this, the subscriber can prove to the telco satisfaction or prove to the government satisfaction for Aadhaar to avail of the benefit that he really is who he claims to be, and he doesn't need to divulge to you his name, his photograph, his date of birth, or his address, or his his fingerprints, or his retinal scans, or any other biometrics. He doesn't give you any information about himself at all, but you can verify that he really is who he claims to be.
That was an amazing answer. I never thought about integrating technology with insects and their movements. That was
Oh, yeah,
amazing.
yeah, absolutely. We have had these routing models for the last 2, 3 years because models from nature are actually optimized because of evolution. So fungus and insects are very good at solving these kind of problems, which humans are. They're outside, in fact, the scope of human intelligence or human creativity.
Yeah.
Yes. Yes.
So moving on to the next question. So we've already seen that AI and predictive analytics can solve customer issues before they even arise. So we can now predict when our systems will be down and fix them before that. So, what more do you think AI can do for the telecom sector?
Telcos are already using AI, artificial intelligence, for network optimization, preventive maintenance using predictive analytics, RPA, that's robotic process automation, and then virtual assistance chatbots, in which Engati, all of you at Engati are the world leaders. So again, if you look at SONs, that's the self-optimizing networks, they use AI, big data analytics, pattern recognition to automatically optimize network quality in real time based on the traffic data by area, location, as well as by time. But as I said earlier, you can get the best kind of self optimizing networks, not based on artificial intelligence systems based on human reasoning, but really based on artificial systems based on, as I said, the fungnet of fungi, or the anternet of how ants solve these rooting problems. In fact, those are better models to use than any of the current models in place for network routing and network optimizations and rollouts. So again, as I said, Fusarium polycephalum is one that has been used for the last 2 3 years to for optimized rollouts, because you don't want to spend time and effort and money in rolling out a network before the customers are there. But on the other hand, you won't get your customers until your network is there. So it's like a chicken and an egg problem, but you solve it like you roll out your network in phases that as your customers are ready, you roll out your networks, and that is where this amoeba polycephalum, uh, Fusarium polycephalum is really excellent at telling you when and where and to roll out your networks and the phases in which you should roll out your network. And again, as I said, bees are very good and ants. In fact, if you look at the mathematical equations of the way bees and ants optimize traffic in going to the hives and returning to the hives, and the way they avoid network congestion, it is exactly the same as the internet routing protocols. And also, when you have server loads, for instance, we have seen massive increases in server traffic during the during the T20 World Cup last year, or during the Football World Cup. So when you have those surges in traffic, as let's say somebody hits a six or somebody scores a goal, or when there was that super over in the World Cup final, you had a sudden surge in traffic based compared to what it was 2 minutes earlier before the final overs. So the mathematical equations of the way ants and bees go to their hives is exactly the same as these types of server balancing and server optimization protocols that you use and the algorithms that you use. You'd also asked a question about preventive maintenance and predictive analytics. So AI can help in the root cause analysis of these possible failure modes. And in India, we've seen that the infrastructure equipment that's most prone to failure are the power supplies for base stations and the towers, and the power lines, and then the power lines to the data centers. So some telcos have started using drones to take video coverage of the base station so they can see when there is going to be a potential failure in the base station.
Customer service is a very critical aspect for the telecom industry. AI powered chatbots can play a very crucial role over here. What's your views on this?
Well, considering that all of you at Engati are a technological world leader in developing chatbots, I don't think I can tell you about chatbots which all of you at Engati don't already know. Now, regarding RPA, robotic process automation, that is being used quite a bit nowadays. What RPA does is that it automates the repetitive and rules-based business processes, such as customer acquisition, data entry. And this improves reliability and speed. It reduces the human errors involved in manual processing by the customer service representatives. Now, in India, we've seen that most of the customer complaints at the customer premises equipment are related to the Wi-Fi routers, the modems, set-top boxes. And actually, a lot of these are very simple solutions, most of the time involving a simple reset or a reboot. So chatbots as well as the AR, VR, augmented reality or virtual reality can guide the customers to solve these problems themselves. Especially because your customer service engineers cannot go to the customers' houses anymore because of COVID. The other thing about chatbots in India is the challenge is to develop the chatbots in all the regional languages. And for that, you need to understand the linguistic nuances and the typical people's behavior in those regions. And for that, you can use NLP. But I don't need to tell you all this. You and got to know all this. Now, again, if you go back to the larger issues of big data analytics and AI, artificial intelligence, machine learning, deep learning, the telcos possess a huge amount of customer data as well as metadata about each customer, location data, historical data, calling patterns. So these can be used to build a detailed profile of each individual, each person, as well as his family and others. So big data analytics and AI can be used for customized marketing of different products and services, targeted advertising. The telcos can tie up with the e-commerce, the electronic commerce companies for targeted marketing of a wide range of products and services. Um, and then machine learning, big data analytics can also be used for fraud detection, as well as for the prevention of customer churn, because they can measure and analyze and predict customer satisfaction levels.
Yeah, yeah.
Yeah.
So, with the increased implementation of 5G, what new trends will we see in terms of increased connectivity, smart cities, and so on?
We have to think of 5G not as an extension of 4G, but in the COVID era as an enabler of a whole new way of living and working. So there needs to be a change in mindset about 5G. And there will be multiplier benefits of 5G for the economy as a whole. Smart cities, smart factories, Industry 4.0, telemedicine, teleeducation, virtual reality, augmented reality. So we have to look at 5G as the basic infrastructure for all of these new ways of work, remote working, both in industry as well as in the services sector, manufacturing as well as services. Now, the major challenges that I see for 5G and the implementation of 5G in the next few years are going to be at the material level and the device level, because 5G, we're really pushing the limits of silicon as a material. Most of the 5G chips which have been designed use FinFET transistors at 5 nanometers logic nodes. But these 5 nanometer circuits are not yet in production, even though the designs have been done a few months ago, because there are problems such as short channel effects, and then there are numerous other problems at the silicon material level and at the device level. And also the manufacturing technologies on the wafer fabrication to manufacture these 5G circuits. So the current production of these FinFET circuits is at the 7 nanometers logic node level, but there is a push now in the last 3-4 months to use an emerging technology called gate-all-around FETs at 3 nanometers. And then there is another emerging technology, second emerging technology, which is called nanosheet FETs. That's also at 3 nanometers. But using both these gate-all-around FETs and nanosheet FETs, they require massive improvements in technologies of lithography, etching, deposition. That is the chemical vapor deposition, the physical vapor deposition, the MOCVD, the metal organic chemical vapor deposition, and also in the packaging technologies. So, in fact, we need a new emerging lithography technology called EUV, extreme ultraviolet lithography. But again, there are severe problems which are being faced in the manufacture of the 5G chips, One is really at the copper interconnection level, where the copper connects with the silicon, and also where there are problems in the deposition of the tantalum nitride layers. And I don't expect these problems to be solved easily. They're very, very difficult problems to solve, and a lot of researchers are working on these. So probably 2026, 2027 is a realistic time frame for these kind of problems at the copper interconnection level to be solved. So I think these 5G circuits using the gate all around FETs or the nanosheet FETs at 3 nanometers, we'll have to wait till about 2026, 2027. As I said, right now we're at the 7 nanometers circuits are being produced. But the designs of a 5 nanometers, but what's being produced is in actual fact, is 7 nanometers. Another challenge that you're going to see at these 5 nanometer circuits is that they're affected by the cosmic rays that come from the sun. So these cosmic rays that come from the sun cause numerous errors at the chip level. And so error correction is required at the chip level itself. Now, this is again a difficult problem to solve. This requires a lot of, you have to solve the problems in quantum mechanics. You have to develop algorithms for error correction at the chip level itself. Regarding 5G rollouts and implementation, you have one kind of infrastructural bottleneck, which is that 5G has a very short range, 300 meters to 500 meters, because the millimeter waves are near line of sight. So you require a large number of base stations, repeaters, and boosters. The other problem with 5G is that they're very vulnerable to weather, to rain, and to other environmental conditions. Even small, moderate amounts of rainfall, they absorb the signals between the base station and the receivers. Yeah, so that okay. One point I want to make about the future of 5G, or really more about quantum communications and quantum computing, is that the regulators' obsession with net neutrality. The regulators in all the countries are hell bent on enforcing net neutrality. And my opinion is that this net neutrality is detrimental to the implementation of quantum communications and quantum computing. And in my opinion, this whole concept of net neutrality needs to be junked, totally junked. Because the basic problem is that they cannot really consult the technologists much. It is it's consumer activists and lawyers and regulators who propounded net neutrality. And the mistake they're making is they have all these notions of equality and fairness. They're human notions of equality and fairness. And they're trying to extrapolate their human notions of equality and fairness onto the natural world. But electrons don't, electrons obey the laws of statistical quantum mechanics. Electrons and data packets don't operate the regulations which are dreamed up by the FCC, USA's Federal Communications Commission, or UK's Ofcom, or the regulations dreamed up by TRAI on net neutrality. That's the Telecom Regulatory Authority of India. Because one data packet doesn't get its feelings hurt if another data packet is given preferential treatment over it. See, nature is full of unintended unfairness. Telecom networks are full of unintended unfairness. And what happens is these regulators obsessed with net neutrality are trying to impose human notions of fairness and equality onto networks which don't care about equality and fairness. So, when these consumer activists push for strict net neutrality, and we have seen the big backlash in the US as well as in India, the misconception that they're making, especially when it comes to quantum computing and quantum communications, is that these non-technical people, and they have good intentions, but they're non-technical people, and they're under misconceptions that the data packets flow from source to destination in an orderly linear queue. Like I told you about the ants move in an orderly linear queue.
Yeah.
But in reality, what is happening is that the data packets move in a general direction towards their destination in a stampede, in a mad rush, in a stampede. The analogy I want to give is like it's when the sperm cells rush to fertilize an egg. Each sperm cell is rushing to be the first to fertilize the egg, and they actually jostle out the other sperm cells out and try to impede the movement of other sperm cells. So similarly, what you're having in quantum communications is that each data packet is in a rush to be the first to reach its destination. And then they try to impede the progress of other data packets. So it's not a linear line of orderly moving of data packets from one place to the other. They just move in a stampede in the general direction of their destination. So you cannot have net neutrality in stochastic, statistically multiplexed, packet switched, distributed computing networks. Now, let's just give the analogy to the Heisenberg uncertainty principle in quantum mechanics.
Okay.
In the Heisenberg uncertainty principle, you cannot determine both the position and momentum of a particle simultaneously. So similarly, in these emerging networks, the quantum networks, at a given traffic density, you cannot determine both the packet loss and the packet delay simultaneously. But just like in the Heisenberg uncertainty principle, you have delta x cross delta px greater than or equal to h bar by 2. So you can put bounds on the packet loss and the packet delay. And this is IPv6 is already doing this. The other thing is that when the regulators say that there should be no preferential fast lanes, no paid prioritization, no preferential fast lanes. Now, if you know game theory, the famous prisoner's dilemma game done by John Nash, the beautiful mind Nobel laureate. So most people have heard of the prisoner's game dilemma game theory. But there is a very complicated game called the stag versus hare hunting game. And in fact, this was first enunciated long ago by Rousseau. And there's another complicated game called the Battle of the Sexes game. So 5G, IPv6 protocols, and then the data packets in quantum computing and quantum communications are modeled by the stag versus hare game. And that's especially at the peering points. Now, regarding game theory, bacteria are very good at solving these game theory types of problems, which human beings find difficult to understand, let alone solve. In fact, the ways bacteria go around solving these game theory types of problems are something which is almost outside the imagination of human experience and human ways of thinking. So developing insights to developing new algorithms for these future quantum networks would come from studying how bacteria solve these kind of optimization kinds of problems of game theory. So I've been saying for years that net neutrality is a solution which does not work to a problem which does not exist. Let me repeat. Net neutrality is a solution which does not work to a problem which does not exist. And in fact, even long cherished concepts in telecom economics like common carriage might need to be junked. Because you look at Reliance Geo, it's blurring the differences between carriage and content because they're using their access networks to deliver their content. And similarly, people are getting onto their access networks because of their content. So the lines of telcos providing both carriage and content is an emerging business model, which is very successful. So I
Yeah.
think we need to do away with some of these outmoded ways of thinking which stand in the way of both technological progress as well as business efficiency.
Yeah,
Yeah.
that's a completely new take on net neutrality for me, and I think you've changed my mind on that.
Okay. Yeah, because as I said, it's it's most of the 5G telecom operators. They all oppose telecom. They strict net neutrality, and in fact, if you want quantum computing and quantum communications, you have to do away with the regulators' kind of ID freaks on net neutrality.
Yeah.
Yeah.
Thanks a lot, Ravi. Those were some amazing insights, right from connecting the nature to technology to net neutrality. That was amazing.
Oh, okay. Thank you so much. It's a real pleasure speaking with you.
Th-
Really.
thank,
speaking with
Yeah.
all of you, Engati.
Thank you so much, Ravi, for giving us your time. Your insights were really valuable, and I know
Oh,
our audience is really going to enjoy this interview.
yeah. Oh, okay. Thank you so much. Have a great day.
Yeah,
Have a wonderful day.
we will be back with a new episode with a brand new expert soon. So stay tuned, and we'll see you around for the next one.
Yeah.